All right, welcome. Today we're going to unravel the incredible forces that keep our oceans in constant motion.
You know that feeling when you're standing by the sea and just watching it? It's never, ever still. So what's really going on out there? What powerful forces are at play?
Well, it's not just one thing. The answer is this incredible trio of forces. You've got energy from the wind, the gravitational pull from space, and these huge hidden rivers flowing deep within the ocean itself.
So let's dive right in. First up, the one we're all familiar with, waves. Okay, so here's a huge misconception a lot of people have. You see a wave and you think it's a big pile of water traveling across the sea, right? Actually, no. It's not the water that's moving, it's energy. Think of it like a pulse of energy passing through the water, making the water particles just kind of bob up and down in little circles.
And if you want to sound like you know what you're talking about, you just need a few key terms. The very highest point, that's the crest. The lowest point in the valley is the trough. Simple enough. Now, the vertical distance from that trough all the way up to the crest, that's your wave height. And the distance from one crest to the very next one, that's the wavelength.
So where does all that energy even come from? Well, it's pretty much all about the wind. And it's a simple formula, really. The stronger the wind, the longer it blows, and the bigger the patch of ocean it covers, the more energy gets transferred, and the bigger the waves get. It's that direct.
Okay, so that's waves. Now let's shift gears to a force that is quite literally out of this world. Let's talk about tides.
So if waves are energy moving horizontally across the water, tides are something totally different. This is the whole ocean kind of breathing in and out, a massive, predictable, vertical movement of the sea level itself.
So who's pulling the strings in this cosmic dance? It's both the sun and the moon. But here's the kicker. Even though the sun is absolutely massive, the moon is so much closer to us, that proximity makes its gravitational pull the main event. In fact, its effect on our tides is about twice as strong as the sun's.
This is so cool. It explains why there are two high tides on Earth at any given time. Check it out. On the side of the Earth facing the moon's gravity literally pulls the ocean water towards it, creating a bulge. But what about the other side? Well, as the Earth spins, a centrifugal force, kind of like the force that pushes you to the side on a merry-go-round, creates a second bulge on the opposite side. So, as our planet rotates, we pass through both of these bulges, giving most places two high tides every day.
Right, so the sun's pull might be the backup singer here, but its position is super important. When the sun, moon, and Earth all line up during a new or full moon, their gravitational forces team up. Bam! You get these extra high tides and extra low tides, called spring tides. But when the sun and moon are at a right angle to each other, they're basically in a cosmic tug of war, kind of canceling each other out. And that's when you get these much weaker tides, called neap tides.
And if you want to see just how dramatic this can be, you have to look at the Bay of Fundy in Canada. The shape of the bay acts like a giant funnel, and it amplifies the tides like you wouldn't believe. We're talking a difference of up to 15 or 16 meters. That's like a 5-story building's worth of water rising and falling every single day. Just incredible.
All right, we've done waves and tides. Now for the final piece of our ocean puzzle, the huge, hidden world of currents.
This is the absolute best way to picture it. Rivers in the ocean. Seriously, these are massive, continuous streams of water flowing in a specific direction, all within the bigger ocean. It's a whole hidden network of waterways.
And when you look at a map like this, you can see it's basically the Earth's circulatory system. Just like blood vessels carry warmth and nutrients around our bodies, these ocean currents are constantly moving heat from the hot parts of the planet to the cold parts. They're a massive global thermostat.
And it really all boils down to one thing: temperature. You've got your warm currents, which flow from the equator up towards the poles, carrying all that warm tropical water. Then you have the cold currents, doing the opposite, bringing that frigid polar water back down towards the equator. It's a constant exchange.
Okay, so we've got waves, tides, and currents. Pretty cool stuff, but why does any of it actually matter to us? What's the big deal?
Well, the impact is everything. Seriously, the stuff you buy gets here on ships that have to navigate these currents and tides. The weather you experience, it's massively influenced by whether a warm or cold current is flowing nearby. And where these warm and cold currents crash into each other, that's where you find the best fishing spots in the world. So yeah, they affect our economy, our climate, and even what's on our dinner plates.
So these forces, waves, tides, currents,
They've been shaping our planet for millions of years. They're like the very heartbeat of the Earth. But that leaves us with one really big question for the future. As we change our planet's climate, what happens when we start changing that heartbeat?